Today, we are going to be covering the division rules for exponents. And not quite as beefy as yesterday, we're just going to be doing numbers 37 through 48. Now, what are the division rules? Okay, very valid question. So this poster, again, in the front, you'll see the quotient rule. And it's going to look like this. X to the m over x to the n is equal to x to the m minus n. So let's use this. In number 37, we have 8p over p to the fourth. Now, some of you probably want to write this down and remember it. That numerator's p has an invisible exponent of 1. We can't forget that. So, does the 8 have anything to work with in the denominator? Any numbers it could try to simplify with? No. So, 8 is part of our answer. For our exponents, for our p, we do its numerator minus denominator exponent. So that's 1 minus 4. 1 minus 4 is negative 3. Now there's something we haven't seen in a couple of days, a negative exponent. We cannot have a negative exponent in our answer, but that's okay. We know what to do here. We have to make a fraction and ask ourselves, we have two things, 8 and p to the negative third. Is there any issue with the 8? No, it has no exponent, so it's fine to be part of the numerator, but the p has to drop. And when we drop it, its exponent becomes positive. So we end with 8 over p to the third power. In number 38, when we look at the fraction, so in the numerator, we can combine the v's by doing v to the 3 minus 3. The 2, which is in the denominator, doesn't have any other numbers to work with. Every other number here is an exponent. So it's just going to be there. So what is v to the 3 minus 3? Well, that's v to the 0. And anything to the 0 power has a value of 1. So actually, we lose our variable here, and we wind up with 1/2. In number 39, we have a fraction, and we have numbers in the numerator and denominator, so we're going to have a fraction when we simplify. 3 and 7 cannot clean up at all, so we're going to leave those. For the b's, in the numerator, we will do the b to the 2 minus 2. And of course, 2 minus 2 is 0, so we have 3b to the 0 over 7. But we know that b to the 0 is secretly just the number 1. So really, we have 3 times 1, which is 3 over 7. Another problem where our variable canceled completely. And if you look at 38 and 39, you'll notice that the exponents were identical in the numerator and denominator. And when that happens, you're going to lose your variable. At this point, you can pause and attempt 40 through 42, and then come back for number 43. In number 40, so we have 6 and we have 4. Now these are both even, meaning we actually can simplify them. So remember, 6 over 4, I can cut those both in half and make it 3 over 2. And that's actually the final answer. Look at your a's. They both have an exponent of 3. So there's nothing to be done with those. They cancel each other out. Number 41, first time in a little while that variables don't cancel out. So we have our 4 and we have our 5, and you can't do anything to 4 and 5 to clean it up. But we do have different exponents on the end. So we're going to do 3 minus 2 in the numerator. 3 minus 2, of course, is 1. So we can write 4n to the first over 5, or we can just write 4n over 5. In number 42, the variables, the x has the same exponent, the invisible 1. That means they cancel out. So all we have left are the 5 and the 8. There's no simplifying to be done with just a 5 and just an 8. Okay. 43 to 48, we're just introducing extra variables. So nothing majorly different. We have the 2, we have the 7, and there's no cleaning up to be done there. For the a's, we have 1 minus 2. For the b's, we have 3 minus 3. Which means we have 2 and 7. A gets a -1 exponent, b gets a 0 exponent when we do our combining. Now we're already living in a fraction, which is good. The a has a negative exponent, so it needs to drop down and join the 7. And the b to the 0 is secretly a 1, so we don't need it. As always, I do not care if you write the 1 as the exponent on the a, or if you don't write the 1 on the exponent of the a. Makes no difference to me, they're the same thing. Number 44. Notice real fast that 6 over 3 is really 2, or 2 over 1 if you prefer. So 6 over 3 is 2. For our x's, we have 3 minus 1. For our y's, we have 3 minus 2. Simplifying, 3 minus 1 gives us an exponent of 2 on the x, and 3 minus 2 gives us an exponent of 1 on the y. So you can write that as 2x squared y to the first, or you can just write it as 2x squared y. In number 45, we have an 8 and a 7 in our fraction as our numerator and denominator values. We can't simplify those, so we're going to have them. X's, we're going to have x to the 2 minus 3, and there is just the y to the fourth in the numerator. Simplifying, we get 8x to the -1, y to the fourth over 7. That negative exponent is a problem. So the 8 can stay where it is, the y to the fourth can stay where it is, but the x needs to drop into the denominator and join the 7, strictly so its exponent can be positive instead of negative. And as always, you do not have to write the exponent of 1. I will happily take 8y to the fourth over 7x as well. In number 46, we will have v to the 1 minus 2 over 6u. Combining my two v's into a single v. And now simplifying. We get v to the -1 over 6u. That v, with its negative exponent, has to drop into the denominator. And since we've cleaned out the numerator, we need to write a 1 in it. Numerators cannot completely disappear. If they clean out, it's not a big deal. We just have to remember to place a 1 there to illustrate, hey, this is still a fraction. Number 47, the 3 and the 5 are boring. Can't do anything to clean them up. For the m, we have a 1 minus 3, and for n, we have 3 minus 2. So when we simplify those, we're going to get 3m to the -2nd, n to the positive first, over 5. The m has a negative exponent, so it must drop. So we have 3n to the first over 5m to the 2nd, or 3n over 5m to the 2nd. Finally, for number 48, 7 and 3 cannot simplify. For our x's, we're going to do 3 minus 3. For our y's, we're going to do 2 minus 3. That gets us 7x to the 0, y to the -1 over 3. 7 is fine. The x to the 0 is a 1, so we don't need it. It's gone. The y has to drop down and join the 3 because of its negative exponent. As always, I don't particularly care if you have to write 7 over 3y to the first or 7 over 3y. They are the exact same.